Ben and John. Yes, I think we are, and then I can send it to you.
Got a message to say we're recording. So hi, Morgan and John are here, and we're looking at EchoOne in Pliteq. Morgan's going to give us a quick intro. Thanks, Morgan.
Yeah, very professionally from my car. So what I wanted to show you first was just when you come to the website, you need to start by going to pliteq.com.au. This website unto itself is actually quite helpful if you wanted to learn more about our products. And there's a lot of really great data in our brochures that provides more of a high level overview. If you want to access EchoOne, which is the really powerful online portal that includes, I think it's currently close to 950 third-party lab test reports and all the associated data, as well as conference papers and various calculators. Then you go over here to this little teeny tiny EchoOne. So in the top right-hand corner.
Top right.
Yep, and you click on that, and it will take you to EchoOne, which is right here. Nice. You will have to be set up with login credentials, but Ben and John and I will just make sure that there's credentials that are set up for you. And Ben and John, we can talk whether that's like individual or it's more of like a classroom credential. So yeah, we can discuss that. But needless to say, Search Test Database is where all of the lab test reports and data will be found. We have new featured test reports. That's where we put the most recent third-party lab tested assemblies, because acoustic consultants that are used to using this tool constantly, they'll ask us, what's new? And so we just thought anything that's done in the last, I believe it's 3 months, we put up there so that people can see the newest data that we've added. Nice. Conference papers, there is a treasure trove of wonderful technical information here. These are all from papers that we have presented over the years. It's also interesting to see how things evolve as time goes on, right? So we break them out by product class. So GenieMat RST is an acoustic underlay that's used directly beneath hard surface flooring. GenieMat FF, which stands for floating floor, is a dimpled rubber product that isolates a floating topping off the structure of the building. So you can just see some examples: long-term performance of underlayments, mechanical and electrical room application, GenieMat Fit. We do a lot of fitness and recreational projects, so predicting impulsive noise emission and compliance with the AAAC gymnasium guideline criteria. Lightweight timber floors using low frequency impact source. So the whole paper and associated data can be found here. Something that's a little bit more just like not so intuitive, if you want to back out, just click on Pliteq EchoOne. It will take you back to where all those tiles are. White papers, again, a lot of really helpful information. They just maybe never became full-on presentations at conferences. But you can look there. Sound isolation project applications. We tried to just make things a little bit more palatable, so you can look at the ASTM or ISO documentation. I'll download one just as an example. So cross-laminated timber design using a resiliently mounted ceiling. Oh no, I don't want to do that. I just wanted to download it. Oh, here we go.
It's maybe opening another window here, which is
that's
shared.
Exactly where it is.
That's all right.
So it won't let me share it. Anyways, give me a moment.
Don't worry.
The one thing I would say is, like, what we try to do is just summarize it with a section detail. We address any of the performance criteria as per the building code. And then we also make sure that we include both the data as well as the file for the third-party lab test report, which is the source for that data. So we find acoustic consultants like these. We call them SIPAs, S-I-P-A, Sound Isolation Project Applications. It's a nice document to share with an architect or a builder, because you don't need to like get all the way into the detail of it. You can provide a really nice high-level overview as to why something is recommended. And then we can hop back to the tiles. There are single degree of freedom calculators.
Nice tools.
There's also 2 degree of freedom calculators. This is a tool showcasing our products and how they will function. But as a quick example, you can choose which isolation product or system you want to look at. You can choose what the floor load will be. and then choose whether it's vented or not. And then it will calculate, the natural, the transmissibility, the percent isolation, and then the reduction in dB as per, each 1/3 octave band.
Right.
I don't know why it didn't actually show what the natural, I don't know why it's not showing the natural frequency of the system.
Is it not here? 17.15 hertz.
Oh yes, there it is. Total system. Sorry, thank you.
Yeah, no worries.
You guys, your videos were just blocking that, so I couldn't actually see it. So thank you, Ben.
Okay, yeah, no worries.
Yeah, and let's go back. So that's the single degree of freedom calculator. Of course, there's a lot of times where it's mostly going to be 2 degrees of freedom, right? Because if you're dealing with a slab that's on an upper level, that wouldn't be infinitely stiff. So then you can look at the 2 degree of freedom calculator, and there are more parameters that we require, of course, like we need to know the floating floor load, the structural floor load, and the natural frequency of the structural floor. And then, of course, you choose which isolation product you're going to use. And the same thing, it will calculate it, but of course, it's 2 degrees of freedom. So you'll see a much different...
2 resonant frequencies. Cool,
exactly.
how good.
Yeah.
This is going to link really nicely with the topics that we're offering in weeks 7 and 8 and 9 of this course.
Oh, good.
So exciting.
Well, yeah, no, I'm glad that this will be helpful. So then let's hop back to the tiles and heavy hard impact prediction modeling. This is a very interesting system that we've put together that allow consultants to do field testing without having to lug 12 different fitness tiles and systems that you drop weights on. I won't get into the details of it, but perhaps it could be a presentation that your students and you would find interesting, because we essentially understand how the structure responds to a calibrated impact on a calibrated sheet. And by understanding how the structure responds, we can model various systems. And it means that it can be a much more straightforward process for the acoustic consultant. Okay, so I'm just going to hop to the search test database. I'll show you, a couple of the main ways that this is a helpful tool. First of all, there's 3 different places to look here. There's find reports, there's selected reports, and then there's the graph. So we have it all organized by structure. So typically we see people starting here. Am I looking at heavy, hard fitness type data? The one thing I should say, I always say this is full of third-party lab test data. The one place where we capture data ourselves is in our drop tower, which again would be something I could elaborate on during a more detailed presentation. All of the other lab test reports in here are third-party lab test reports unless they're clearly shown as field tests. So whenever you're comparing things, obviously best practice is if you can choose the same lab, if you can even choose the same dates. We really try to do a lot of single variable analysis. If we're getting a lab for a week, let's do single variable analysis so that we can actually provide this tool for comparisons. So yeah, you can see concrete slab 152 millimeters. That would just be bare without any ceiling and without any floating floor on the top side. Then you can see that there are many different iterations. Composite deck.
Right.
That's what we
progressively changing one variable, as you say. So going from adding this to adding something else to adding. So
well, kind of, but it's actually within each structure that you'll see. Like here, I'll show you as an example. 152 millimeter slab. Granted that we're a Canadian company and a lot of the testing that we've done over the years has kind of been focused on Canadian and American standards, they actually build with a lot of bare 152 millimeter concrete slabs. And so those types of buildings are very reliant on acoustic underlay to meet building code if hard surface flooring is being used. So you can see even just bare concrete slab at 152 millimeter thickness, there are 34 reports.
I see.
Right? So then you start, we try to show the cross-section detail. We of course summarize the RW. We do have the RW plus CTR and of course the LNW as well. Each report will be summarized like this so you can quickly look through them. And then if you wanted to compare assemblies, I'm actually just going to go to my selected reports and unselect them all so we can just kind of start fresh here. We did some mass timber comparisons. That's what I was doing the last time I had this open. And I think we have around 185 mass timber assemblies that have been tested. So I'm just going to hop back to find reports. I'm going to randomly choose a couple of these. So you can click select. You can click, let's get a bare concrete slab just because it's a nice baseline to have. And then let's choose one with a ceiling. And then let's choose one with the carpet tile and maybe porcelain tile with a 5mm genie mat underlay. So if we go to selected reports, we're going to see that those 5 have been selected. There they are. And then we can go to graphs. And it always says this graph can't be rendered. It shouldn't say those words. It should say, hold on a second, I'm thinking. Because it always does end up coming through. So then you can see we are showing those comparisons, right? We've got our normalized impact sound pressure level in dBs, and we've got our 1/3 octave band frequencies. And then we've got the legend down here, and you can see the impact sound transmission. You can click on airborne sound transmission. Well, yep. And then if there is Tachibana ball data, it will be there. Not all of the assemblies have had that standard done to them. So you can see those ones don't, but we do have one graph there. And that's how the tool works. Again, the only thing that I believe will not be there for you is to actually download the graphs, although we do give that to the consultants. So anyways, you can save these graphs and everything within your own version of EchoOne. So you can save the graphs and the comparisons. You can share them with people in your organization. You know, if you wanted to send something to your students or whatever, you can do that. And let me just go back to find reports because
sorry, just on that topic, it might be helpful if there's an institution level login that's available just to students, and then if John perhaps and myself had our own logins, then we could save reports and share with one another, and then push perhaps to the institution level login, which would just could be from anyone from a cohort of candidates. That might be a way to begin.
Yeah, no, that's good feedback for sure. Yeah, like professor. Well, but Ben and John, you'll each just have your own, and
exactly.
Then we'll create.
They can have the same profile, just separate logins, so that when we save things, they're still there when we next log in, and the students can just it's a bit of a free for all for them.
For sure. So I'll just use a different structure because again, there's some really interesting stuff here. These composite decks, that's like lightweight steel, right? Where they've got like a metal pan deck and they fill it, but with less concrete. So there's a number of assemblies there. And then all the mass timber reports that we've done over the years. And not only is it like cross laminated timber, we have it broken out by 3-ply, 5-ply, and not only one type of 5-ply, we have 4 different manufacturers and 4 different thicknesses, and then 7-ply, and then dowel laminated timber, mass plywood panel, nail laminated timber. So one of the things we really do focus on is when we start seeing trends, of new structural things or new finished flooring or whatever it may be, we try to get ahead of the curve by proactively testing on these types of structures so that acoustics is never the reason that an architect or a builder or a developer would say no. So it's been really fun with regards to mass timber in particular. We've become really great resources to the designers, the builders, the developers by saying, you don't need to worry about acoustics. Here's your third-party lab test, your deemed to satisfy report to show that you can and should keep evaluating using mass timber. It is a very sustainable way to build. So I'm just going to grab something here because what I want to show you is this is the case for all of the reports that we have in EchoOne. But if we look at I don't know, let's just do these. There's a lot of wet trade, like cementitious toppings that are used in North America. We also have a lot of dry assemblies. I'm just going to arbitrarily choose one here to show you some of the functionality here. Whenever you see this, we summarize it at the top. We show the section detail. We show what standards it was tested to. You will have your profile defaulting to ISO standards. If you ever wanted to look at ASTM data, you just change your profile to ASTM. We feel very confident that going from ASTM standards to ISO standards is a very accurate way to do it. We have a whole paper written on that if you wanted to read more about that. We then show all of the components that are in that section detail, and you from there can click on View Report, and the full report for your team to scrutinize and look at all of the various details is right there for you to see. We think that's, you know, exceptionally important because we see how a lot of things can be tampered with and played with so that, you know, criteria and performance is sometimes, yeah, I won't dwell on that, but just I want to show that there's a cover page that we create and then the full report for you to look at. So this one was done at Pliteq. You can see exactly what the scope of work is, the specimen, the report number, the test date, on and on and on. There's 14 pages. All 14 will be there for you to look at. So I just wanted to share that source data, the actual report is there for you.
Yeah, right. Nice.
So I think with regards to an overview and trying to keep it concise and something that you can easily share with your students and also use as a resource, that's pretty much what I will cover. You could, I don't know what of these capabilities will keep there for you, but if the yellow buttons are there for you, you could download DWG or PDF section details. If that's helpful, you can also just screenshot them, right? They're there for you if you need them.
Very good.
Very good.
All right.
How long has this been under development? You've managed to sort of somehow, over a long period of time, surely to get all of this data, have, you know, a great degree of control over how these things are implemented and executed so that all of these fields, you know, are populated for all of these different tests. That's quite, you know, somebody at some point had a clear vision.
This somebodies were Paul Downey and Will Byrick. Paul, the CEO and founder and patent holder, he just truly believes that third-party lab test data is what is so important to the acoustic consultants. We commit to putting 6% of our annual revenues back into R&D every year so that we can continue to test new assemblies and enter new markets and, again, make sure we're staying ahead of trends. So, yeah, it's been decades in the making. With that said, we also believe that tests in the last 10 years really should only be the relevant ones that we have published. So we are constantly getting rid of ones that we deem are too out of date,
right?
Because building materials change, right? Things get lighter. People, you know, different manufacturers of plaster boards or steel studs, like that actually can slightly change and have an impact on acoustic performance. So yeah, we were doing some analysis on this, and we do believe that this represents about $15 million of R&D over the last 20 years.
It's a good chunk of investment.
Yeah, that's good.
Yeah.
So with the drop test, are you doing drop tests over the chamber or separate to that?
So when we're looking at, so when it comes to heavy, hard impact data, so this is for fitness, where we're really concerned about large, heavy, hard sources of impact. We've constructed a drop tower in our facility.
Which is a set of source and receiving rooms over a...
It's actually not. I'll send you some photos, and it actually might be worth circling back on this. Because I would say, yeah, there's a number of things that we should dig into more detail that will explain some of the data that's here.
Okay.
But we constructed a drop tower on a 1.2 millimeter thick concrete slab, so infinitely stiff, to understand
1.2 meter, not 1.2 millimeter. Did you say?
1.2 meters, 1200
Right.
millimeters,
Yeah.
so that it was infinitely stiff, so that we could actually really start understanding just the response of the material from a force pulse standpoint. Because that to us was a very objective, apples to apples way to understand the efficacy of products. And so it's because of that drop tower that we're able to do all this prediction modeling.
Makes sense.
And really understand contact time of the source. So anyway, I could ramble on about it, but maybe that's another.
I just picked up on that because I wanted to mention that we have a drop tower. We obviously tried and failed a little bit previously with respect to, you know, source and receiver room because of the arrangement, which is ours is wall. You're looking for floor ceiling, but we do have drop tower capabilities. They're currently in our Broadway campus, but they'll be at Botany campus sometime in the future. Just FYI, really.
Yeah, no, that's good to know, Ben. I'd love to learn more about your apparatus. We can share details on ours, and yeah. But anyway, I've taken a lot of your time. I hope that this is a helpful resource in your class.
Thank you.
Anyone's welcome to reach out to me if there are any questions or you want to talk about specific structures or challenges.
Yeah,
it's quite
thank you
advanced
very
stuff
much.
for the cohort that we're sort of dealing with. You know, you could create an entire subject on this. But it's certainly something that we want to give some degree of exposure to, and we'll try to work out how to do that, and we'll keep you in the loop. Shall we can the recording and wrap up? Is that a good time?
Yeah, good idea.
Thank you, Morgan.
I actually don't wait. Let me see. Oh gosh. I can talk about acoustics, but I certainly don't know how to use Google Meet. There we are. Stop recording. Okay.
Awesome.